Hello students, today we will discuss about the equilibrium of concurrent forces. It means if we have lot of forces acting at the same point, then what will happen? Suppose there are two forces F1, F2 here are acting at point O. These are different forces, these are not equal forces. Then what will be the equilibrium and non-equilibrium here? Maybe here equilibrium or non-equilibrium. What will happen? We will discuss here. Now there are two forces F1, F2. Then we know the law of vector addition, law of parallelogram. Okay, by that method we can find the resultant of these two vectors. Resultant will be along this line. It will be F1 plus F2. You can see from this diagram here. This is along this direction, F2 force, and F1 is in this direction. Resultant will be here F3 vector. Okay. Consider there are three concurrent forces F1, F2 and F3 acting at O of a body. Suppose here is any body and these forces are acting on that body. By parallelogram law, you will find this. I told you just before seconds. Resultant of F1 and F2 will be F2. It will be F1 plus F2. Vector sum of these two forces F1 plus F2. Vector, we will say vector F1 plus vector F2. Okay. If third force, now suppose students there is any third force and condition is that it is in this direction, or we can say the third force which is applying on this body at same point O is in opposite direction to the resultant of these two forces, then F3 will be equals to minus vector sum of F1 plus F2 here. Okay, F3 is equals to the vector sum of these two forces. Now we can substitute this value here and it will be F1 plus F2 plus F3 will be equals to 0. Here we can say the resultant force acting on this body is 0. In case of concurrent forces, when there are a lot of number of forces applying on the same body at a time, then the vector sum of forces will be equals to 0. If vector sum of these forces are is equals to 0, then body is said to be in equilibrium. It means body either is in a state of rest or moving with a uniform velocity. It will remains in that condition, either in condition of rest or in condition of uniform motion, and body will set in equilibrium condition. If n forces are acting on a body, students, then total vector sum of the forces will be equals to 0 and body is said to be in equilibrium. Okay students, today next topic in this video is Lami's theorem. In this theorem, suppose there are three concurrent forces F1, F2, F3 acting on a same particle which is at point O, and these are in equilibrium conditions. Now the angle between force F2 and F3 is suppose alpha, angle between F3 and F1 is beta, and angle between F1 and F2 is gamma. There are three angles here, alpha, beta and gamma separately. Now we can draw this by vector triangle addition law. Here it is the F3 downwards direction, F1 towards right direction, and here F3 upward direction. Now it makes a triangle ABC. You can find that the angle between F3 and F1 is beta. Here it is the angle. Angle between F1 and F2 is gamma. You can see from here. Angle between F3 and F2 is alpha here. Now what is the value of this? The value of this line is equals to pi or 180. the value of this remaining part will be inside this triangle. It will be equals to pi minus beta, and this will equals to pi minus gamma, and this becomes pi minus alpha. Now applying the law of sines to triangle ABC, we will apply the sine law, and there are two laws, sine laws and cosine laws. Here sine laws, F1 upon the value of force, and the it will be divided by the sine angle in front of this, F1 upon sine pi minus alpha. Similarly, F2 upon sine pi minus beta, and here F3 upon sine pi minus gamma. Now the value of sine 180 minus theta is equals to sine here, or we can write F1 upon sine alpha equals to F2 upon sine beta equals to F3 upon sine gamma. These three values are equal to each other. Now what Lami's theorem says? Lami's theorem says that when these three forces are in equilibrium, then the force will be directly proportional to the sine of the angle between the other two forces. Here Lami's theorem says that the applying force F1 will be directly proportional to the sine of angle between the two remaining forces. Here it is the two remaining forces F2 and F3, and angle between F2 and F3 is alpha. Here forces F2 and remaining forces here are F1 and F3. The sine of will be here beta, and for F3 remaining forces are F1 and F2. Sine will be here of gamma. This is the Lami's theorem.